Welcome, and today we're going to discuss the properties of water. Water is one of the most important molecules on Earth. All living things need water, and living things cannot survive without water. So, there are major properties of water that allow it to be one of the most important things to all living things. The first one is its polarity. So let's go over here and talk about the components of water. Water is made up of an oxygen molecule and two hydrogen molecules. That's why it's H2O. We have the two hydrogen and one oxygen molecule. Now, when they bond together, and you should remember this from prior atom and matter discussions, is that the hydrogen atoms will come in and want to covalently bond with the oxygen atoms. That's the sharing of electrons. Because the oxygen molecule wants to have 8 electrons in its outer level, and it only has the 6. Okay, I want 2 up here, 2 here, 1, and 1. Okay, it wants to have 8. Now the hydrogen wants to have 2 in its outer shell. Remember, you have the different levels of outer shells of electrons. You have the level that wants 2, then the second level wants 8. So the second level here wants 8. These guys want 2. If these electrons come up into this layer, and then our protons come up, and we have our sharing of our electrons here, and this is our outer shell of electrons. So now our oxygen has 8 electrons in its outer layer, and each of our hydrogens have 2 electrons in their outer layer through sharing of their electrons. Okay? We still have the same number of protons and electrons in the entire molecule. Okay? So it's a neutral molecule. They're just sharing those electrons to make sure they have what they need. Okay? So this is our water molecule. But if you notice, all of the electrons are on this side here, on the top half near the oxygen. Now, because of that, this water molecule has one side that is slightly negative, which is the side where all the electrons are. So the top here is what's considered slightly negative. Now, each of these sides have a proton on this side, but no electrons around it. They're up closer this side. So these protons areas are considered slightly positive. This makes the water molecule polar. It has one end that's slightly positive, one end that's slightly positive, one end that's slightly negative, and the entire atom or molecule is still neutral. So it's polar, but it's not charged. Okay? This polarity actually leads into something called hydrogen bonding. Okay? Because we have our slightly positive and our slightly negative sides, our oxygen actually likes to bond with our hydrogen of other water molecules. So if I bring in actually an extra board here, and I start, we have our oxygen molecule here at the top that's joined with our 2 hydrogen molecules. So this is our water molecule. Now another water molecule comes in, and this hydrogen actually gets attracted to the oxygen, and we have our hydrogen and hydrogen here. And so this bond that forms between these two is what's called a hydrogen bond. We still have 2 water molecules here, but it's an attraction between the hydrogen of one and the oxygen of another, which helps those water molecules stick together. Okay? The polarity and the hydrogen bonding actually work well together to allow all of the other properties of water that help living things survive. For instance, cohesion. Now, if you remember the prefix co means together. Okay, so co-workers work together. Cohesion is where two water molecules are going to want to stick together. Okay, and so water actually has a cohesive effect. It wants to stick to other water molecules. The second one is adhesion. Adhesion would be where it would stick, the water molecule would stick to something else. Okay, for instance, it might stick to glass. Many of you have seen the meniscus that's formed in a graduated cylinder. Okay? In a graduated cylinder, the water looks like it's climbing up the sides of the graduated cylinder. And this is because the water likes to stick to the glass. Okay? It also likes to stick to each other, so it's not going to make little water droplets on the glass, but it's going to stick to the water that's down below it, along with pulling up the side of the glass. And that's because the force of adhesion is actually greater than the force of the cohesion. So cohesion is when water molecules want to stick together, stick to each other, and adhesion is when water molecules want to stick to something else. For instance, the glass here. Okay? Those two properties actually work together to help other things within life. Like for instance, the water that wants to move from the roots of a plant up through the stem and into the leaves is because of cohesion and adhesion. Okay? So those two properties actually help with that. A third property is called heat capacity. Now heat capacity is where water actually takes a lot of energy to increase the temperature of water, or to a lot of energy to release to decrease the temperature of the water. Now, think about on a hot summer day when you're out at the ocean, okay? It's a lot cooler, it feels a lot cooler out in the ocean than it does out in the city. And the reason that is because the water is absorbing so much heat and it's not increasing in temperature as much as the surface of the ground. And so this ground surface actually releases a lot of that heat a lot quicker, and the water stays cooler and the city increases its temperature a lot quicker. Okay? So heat capacity is another one. Now, all of these working together, there are a couple of major things that water does. First of all, water, when it freezes, ice is actually less dense than liquid water. Usually it's the other way around. Usually when something goes from a liquid to a solid, it becomes more dense. However, water is actually less dense when it is in the frozen state due to the fact of the hydrogen bonding. It allows spaces there within the water molecules. A second one is that it allows it to dissolve lots of other materials. Okay, the polarity and hydrogen also allow water to dissolve lots of other materials, which gets us into what's called a solution versus a suspension. Okay, there are two different types of dissolved minerals that we have in our water. Now we can have a solution, and a solution is where the materials actually completely dissolve within there. Okay, the water and those pieces are completely mixed up and mixed together. Okay, and they kind of mix together, and you don't have, it forms a mixture. So everything's kind of, you can't separate everything out easily. A suspension, on the other hand, is where you have separate pieces of water and separate pieces of whatever you have mixed together. Okay? So a solution might be like sugar water. When you take and dissolve sugar in the water, what's going to happen is that the water and the sugar are actually going to mix together. You're not going to be able to easily separate them without going through some sort of process. However, suspension would be like if I took little pieces of sand and I mixed it in with the water, they're not actually going to mix together. You're still going to end up with sand and water particles. So a solution is where they completely mix together, and a suspension is where they are separated, and you can separate them very easily. The last piece The last piece that we want to talk about with water is the pH scale. Okay. Now, many of you have seen a pH scale, and you have things called a base, and you have something called an acid, and then you have something else that is neutral. And 7 on the pH scale is neutral, and that is pure water, or pure H2O is neutral, okay? Now, if something is basic, it means that it has a higher concentration of OH minus ions, okay? If something is acidic, it means it has a higher concentration of H plus ions. Now, if you notice, if we mix the two together, OH plus H, we actually get water. So, acids and bases are actually different parts of the water that have kind of split apart. Okay? So bases actually have more of the OH minus, and acids have more of the H plus in them. The further away from neutral that you get, the higher the acidity. So 0 is actually a higher acidity than 6 is. Okay? And the further away from 7 on the other direction you go, the more basic you get. Okay? So 14 is a stronger base than 8 is. Okay? So these are the measures of pH. And when we start measuring those pHs, they kind of work at being able to keep things normal in your body. Now, if we were to mix bases and acids together that were equal strength, we're going to get a neutral. Because if we have something that is a pH of 9, it's got a certain number of OH minus in it. A pH of 5 actually has the same number of H plus ions in it. So if it's the same distance away from 7, it's got the same number of ions in it. So what's going to happen? When we mix them together, those OH and H plus are going to join together, and we're going to form H2O, and we're going to be able to neutralize whatever it is we have. Now, there is one exception to this rule. When you have something inside your acid or your base, and it's called buffering. Okay, when you have a buffer inside your acid or base, what that does is it actually stops the ability of the OH minus or the H plus to be able to kind of join together. So, if you have a very strong base, okay, if you have a very strong base and you have a weak acid, but that acid has been buffered, when you add that strong base, it's actually not going to turn it neutral or turn it back to a base. What's going to end up happening is if it's been buffered, it's going to stay in that acid place. This helps in our bodies a lot. Our bodies actually contain lots of buffers. Our pH of our blood has to maintain a certain pH. And if it goes outside of a certain range of that pH, then we have some major issues within our system. And so we have these buffers in our system that stop the change of that pH to a drastic level. So we maintain levels of pH within our body without having to go drastically into a really far pH if we have something added to our bloodstream. So buffers help maintain homeostasis within organisms. Properties of water. Water is an extremely important piece, okay, for all living things. Without water, living things would not be able to survive.